Hey, welcome to our explainer. Today, we're going to unravel a really cool puzzle. How in the world do we introduce huge subjects like science and technology to our youngest learners? You might be surprised to find out there's a secret formula for it, and it's been hiding in plain sight all along. Okay, let's jump right in.
So, when you hear technology and 5-year-old in the same breath, your mind probably jumps to a kid glued to a tablet, right? But in early education, it means something totally different. It's not about screens, it's about a whole way of thinking. So, how do you actually teach that? The answer isn't what you'd expect. It's not in some flashy new class or a high-tech lab. Nope. For the earliest grades, natural science and technology isn't even its own subject. It's actually cleverly smuggled inside something else. To find it, you have to peek inside the curriculum for the foundation phase. That's grades R through 3. And it's not called science, and it's definitely not called technology. The groundwork for both is being laid in a subject that sounds, well, a lot more general.
That's right, life skills. I know, it sounds almost counterintuitive, doesn't it? But according to the official curriculum, this is exactly where the journey into science and technology begins. This is its home base.
So what even is life skills? Well, it's this big core subject made up of these 4 different parts. But the real key to our whole puzzle, it's hidden inside just one of them. The one that's designed to get their minds ready for the more complicated stuff they'll learn later on. And here it is. It's that slice of the pie called beginning knowledge. But look, it's not just one thing. It's this amazing blend of natural sciences, technology, and social sciences all swirled together. This is the incubator. This is where the magic really starts to happen. But here's where it gets really interesting. The whole approach is probably completely different from how you remember science class. The goal isn't to get kids to memorize a long list of scientific facts. Not at all. It's about building a fundamental toolkit of skills they can use for the rest of their lives.
Exactly. So if it's not about memorizing stuff, then what is it? What does a science and technology lesson actually look like for a first grader? The answer is all in the how, not just the what.
The core idea is something called inquiry-based learning. And really, that's just a fancy way of saying we let children be the explorers. Instead of just being told the answer, they get to develop these crucial science skills by asking their own questions, making predictions, and discovering things for themselves. And why do it this way? Well, because it's just so effective. It gets kids to learn by actually doing things and talking through their ideas. They get their hands dirty with real problem solving in ways that make sense to them, and that helps them develop these amazing qualities like curiosity and persistence. Now, even though natural science and technology are taught together, they really are 2 different ways of looking at the world. And there's a super simple analogy that makes the difference crystal clear. Think of it like this. Natural science is the detective. It's driven by pure curiosity, always asking, why? Why does the world work this way? Meanwhile, technology is the inventor. It's driven by a practical need, always asking, okay, how can we fix this? One wants to understand, the other wants to create. And of course, those different goals mean they build different, though related, sets of skills. The science detective is observing, comparing, and experimenting. The technology inventor is investigating a problem, designing a solution, and then actually building it. Both are all about process and discovery, just with a different endgame. Okay, let's zoom in on that inventor side for a minute. How do you teach a young kid to be a technologist, a real problem solver? You give them a clear, repeatable roadmap. So the curriculum provides this simple but really powerful blueprint for them to follow. It's called the technology design process, and it's basically a framework that guides them from identifying a problem all the way to creating and sharing what they made. It's a whole cycle of innovation. This 5-step process takes them from a question all the way to a creation. It starts with investigating the problem, then it moves to designing a solution. After that, they make it, they evaluate how well it works, and finally, they communicate their results. It's this full cycle of problem solving. Sometimes you'll hear it called IDMEC. Let's see how that actually works. The first step, investigate, is all about understanding. This is where kids brainstorm, talk to each other, and gather info to really get a handle on the problem they're trying to solve. So after they come up with a plan, which is step 2, design, they get to jump into the make stage. And yeah, this is the really fun, hands-on part. It's where kids use materials, whether it's cardboard and tape or sticks and mud, to actually build their solution and bring their ideas to life. So when you put all of these pieces together, the inquiry-based science and the design process technology, you get to the real heart of it all.
This whole thing is about something much, much bigger than just a few classroom activities. The curriculum is actually built to engage the whole child. It has these three big aims. First is doing, which is all the hands-on stuff. Second is understanding, which is the minds-on part where they connect the dots. And third is society and environment, which is hearts-on. It gets them thinking about how their work impacts the world and people around them.
You know, this quote from the source material just says it all. The goal is to provide learners with opportunities to explore ideas and encourage them to come up with their own questions. See, it's not about giving answers. It's about nurturing that natural curiosity they were all born with. Which brings us to the final, most important takeaway here. The real goal of all of this, it isn't just to teach science. It's to build future innovators. It's about creating a generation of thinkers and doers and problem solvers by teaching them a mindset, a way of approaching the world with curiosity and with confidence.
And that really leaves us with a final question to chew on. If we start this young, teaching kids not just a bunch of facts, but the actual process of identifying and solving problems, are we giving them the single most essential tool they'll ever need to build a better future for all of us?